This is 7th grade, lesson 7.2. This is on page 75. Subtitle, Understanding Theoretical Probability. Boy, that's a fancy sounding college term, but it's a lot easier than you think. It's a lot easier than it sounds. Let's look at example 1. So these two individuals, Talia and Yoshi, designed a game for a school fair. Contestants spin the pointer and win a prize. And it lands on either of the two red sections. If it lands on either of the red two sections, how can Talia and Yoshi determine how many people are likely to be the winners if 500 people play their game? Well, first off, you got to count how many possibilities there are in total. And that's what they did right there. It says determine the number of possible outcomes. Okay? And it says, oh, I should probably turn off my tunes before they cancel my video and don't let me upload it. So I'll pause that right there.
Tunes?
My tunes. Music. So there's 16 sections. And if there is one that was only one particular color, then the odds would be 1 out of 16. And it says, because you know all the possible outcomes, we're talking about 16, the theoretical probability of an event such as a pointer landing on red. And so P represents the theoretical probability of an event or an outcome. And it says use proportional reasoning to predict the number of likely winners. So first off, if it was just let's say 16 people playing, well, that just doesn't really matter. We could look at it this way. There's 16 possibilities, and 2 out of 16 are the odds out of the odds that will land on red, which would be the winners, and that can be reduced to 1/8. Okay, but there's 500 people playing this game. And so what they did here is just simply multiply 500 by 1/8. And so you get 62.5 W. So out of the 500 contestants, in other words, if 500 people spun this, they would expect about 62 winners. Now, it might be a little more than that, might be a little less than that, but that's how many winners you would expect. So to try it, down at the bottom, it says if Talia and Yoshi redesigned their spinner to have 14 sections, before it had 16, now it only has 14, it's so they would likely have, would they likely have more or fewer winners? Explain why. Well, it would change from 2 out of 16 to 2 out of 14. And that would reduce down to 1/7. And 1/7 is greater than 1/8. So they would end up with more winners, because if you multiply 1/7 by 500, you're going to have more than 62.5. And let's say maybe half of the possibilities were red. That would be 1/2. And 1/2 times 500 is 250. So the more possibilities, the greater the number of winners you would have, let's say, out of 500 people. So the convince me says, if there are always 2 red sections, how does the number of total selections in the spinner relate to the theoretical probability of winning the game? So I wrote down, as the number of selections or sections increase, the odds of winning will decrease. So look at it this way. Right now, the way they designed it at first, it was 1/8, because there was 2 out of 16. But if there was, let's say, 50 different selections, then it would only be 2 out of 15, or 1/25. If there was 100 different selections, it would only be 2 out of 100, and there'd be 1/50. So it's getting smaller and smaller and smaller, that the odds of somebody winning are pretty slim. So that's why I put down, as the number of selections increase, the odds of winning will decrease. All right, so let's look at example 2. It says Archie plays a word board game. He places 98 letter tiles and 2 blank tiles in a bag. So I just wanted to point out to you, he's got 98 tiles with letters, but 2 of them, you can see them right here, are blank. So that's a total of 100 tiles. Then it says, what's the probability the first tile be drawn will be a blank tile? Well, 2 out of 100, which reduces down to 1 out of 50. Are you gentlemen done, or you want to go to the office to goof off?
No, we're done.
So pretty slim chances, 1 out of 50. And then it says, how about with a letter? Well, that's going to be 98 out of 100, which reduces down to 49 out of 50. So the odds are really good that you're going to pick one of the ones with a letter. And then with a vowel, consonant, and they go over that for you there. Example 3, it says, Joaquin also designs a game for a school fair. Contestants roll 2 numbered cubes at the same time. If the sum of the numbers on the cubes is 7, the player wins. So he's rolling 2 6-sided dice. And a 6-sided dice has the numbers 1, 2, 3, 4, 5, 6 on it. And so the odds actually of rolling a 7 with 2 6-sided dice is the greatest. And so this is what they did here. Here's the first cube in the blue. Here's the second cube. And they've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And they just make a graph here. So if each cube rolls a 1, then that's going to be 2 on the dice, a total of 2. If each cube rolled a 6, what's that going to be? A 12. All right. How many boxes or combinations are possible? Well, they explain it here. It's 36. There's 36 of these boxes. And so the odds of rolling 2 6s, or a total of 12, are pretty slim. It's 1 out of 36. What are the odds of rolling, as they said here, 7? Well, how many 7s are there? 1, 2, 3, 4, 5, 6 7s. And so they go through that, 6 out of 36, and that reduces down to 1/6. And now if there was, again, 500 people participating in this game, you would have about 83 winners, 83.3. So the try it down below kind of relates to example 3. It says Joaquin wants to reduce the number of winners so he does not have to prepare as many prizes. Yeah, preparing 83 prizes would be a lot. It says choose another sum he could use as a winning sum and predict the number of winners if 500 people play the game. And I do want you guys to do this. But I want everybody to use the same number, and it's 5. So I want you to let me know, out of 500 people that play this game, about how many would be winners. And you're using, again, the number 5. Questions on that? Nope? Okay. All right, number 1. I just drew a little arrow up there. It says, how can the probability of an event help you make predictions? You can determine the theoretical probability of an event. They label it P if you know the possible outcomes. And they put, and they are equally likely. I'm not really worried about that. Okay? You can just copy that down. Number 2, It says a game board has a spinner with 10 equal-sized sections. And out of the 10, 4 are green, 3 are blue, that's 7. 2 more are yellow, that's 9, and 1 more is red. And then it says, what is the sum of the probabilities of the pointer landing in green, blue, yellow, and red sections? Well, they just named all the colors on the spinner. So that's 10 out of 10, or 1, or 100%. It's going to happen. There isn't another color. There isn't a white. There isn't a mauve. There isn't a purple. It's going to land on one of those 4 colors they listed. Number 3, it says, what does it mean that there is an equal theoretical probability of each outcome? And I wrote down, each outcome has an equal chance of occurring. Each outcome has an equal chance of occurring. That's what it means if there is an equal theoretical probability. All right, I want you to do 4, 5, and 6. Let's look at 6 together. So it says, if Monique, they're talking about Monique here, and she rolls a 6-sided number cube labeled 1 to 6. Let's see here. If Monique rolls the number cube 12 times, how many times would she expect a number greater than 4 to be rolled? Well, so remember, I'm just going to draw 6 squares. Each one represents one of the sides of the dice. And so it's 1, 2, 3, 4, 5, 6. Those are the 6 sides of that die that she's rolling. And it says, how many times would she expect a number greater than 4 to be rolled? Well, that limits us to what? 5 and 6. All right, so that is 2 out of 6, right? What is 2 out of 6 reduced down to? 1/3, okay. How many times is she rolling it? What's 1/3 of 12? Well, you had your hand up. I thought you were going to answer it. What's that? 4, okay. So 1/3 of 12 is 4. Okay. Make sense? Glad you think so. All right, number 7. Circle that. 8 and 9 and 10. Number 1, I'm sorry, not number 1, number 11, number 12. 12 is a stick. No, it's not graded. 13 and 14, circle those. Questions on this?
No, Mr. Blake.
Okay.
Are we going to have a little bit of free time? Or no?
No,
Or
not
like
today.
frolic?
You got free time right now to work on this.